Consider a circle having center O. Let's consider 3 points A, B and C lying in the interior, exterior and on the circle. We all know what a tangent to the circle is, right? Can you tell me? Yes, a tangent is a line that touches the circle at exactly one point and it never enters the circle interior. Now, by knowing what a tangent is, let's try to draw tangents to the circle from these 3 points we have drawn. Let's try drawing a tangent from this point A lying in the interior of the circle. But is it possible to draw a tangent from this point here? Think and tell me. No, it's not possible. Because a tangent can never lie in the interior of the circle. Now, let's try drawing a tangent from the next point B lying on the circle. First, let me ask you this one question. Is it possible to draw a tangent through this point lying on the circle? Yes, why not? We can draw one tangent through this point B. And how do we do that? We simply draw the radius of the circle from this point B. We all know that the tangent to a circle is always perpendicular to the radius drawn from that point. So, we draw a line perpendicular to this radius. This line is the tangent to the circle at the point B. Now, let's see this point C, which is outside the circle. Let's construct a tangent from this point C. How do we do that? Come, let's see. Firstly, tell me how many tangents to this circle are possible from this point C? 1 or 2 or more than 2? Yes, it's 2. One like this and the other one like this. Let's see how they are constructed. How do we begin? We start by joining the point from which the tangent has to be drawn with the center of the circle. Here, we join the points C and the center of the circle O. What next? We now find the midpoint of the segment CO. And we know how to do that, right? Yes, we draw the perpendicular bisector of CO. With the help of a compass, taking a width approximately greater than half of CO, we draw 2 arcs above and below like this. And then we do the same by keeping the compass at the other point. We get 2 points like this. Now we join these 2 points. This point M is the midpoint of the segment CO. Now, again with the help of a compass, taking the width as the length of MO, we draw a circle with M as the center. What do you observe? At how many points do the circles intersect? Yes, as we can see, this circle drawn intersects our original circle at 2 distinct points. Let's name these points as Q and R. We then join the points CQ and also the points CR. These 2 segments CQ and CR are the required 2 tangents of the circle. Wasn't the construction simple? Yes, it was. But wait, can you tell me why these 2 are tangents to the circle? Look at the circle with center M and observe the angle CQO. This is an angle inscribed in the semicircle. And an angle inscribed in the semicircle is always a right angle. This angle will measure 90 degrees. Hence we can say that CQ is perpendicular to OQ. Because CQ is perpendicular to the radius of the circle with center O, we can say that CQ is a tangent to this circle. In a similar way, even CR is the tangent to this circle. Let me ask you another interesting question. What if we were not given the center of the circle? In our example, we joined C and O if you remember. But what if we didn't have the center O of the circle? Simple. We would then have to find the center. And how do we do that? We just draw 2 non-parallel chords and draw their perpendicular bisectors. The point where they intersect will be the center of the circle. So let me quickly review the steps of drawing a tangent to a circle from an external point. We join the external point with the center of the circle. Then we draw the perpendicular bisector of this segment. Then from the midpoint, we draw a circle with radius equal to this length. And the last step is to draw the segments from the external points to these points of intersection. These two are the tangents to the circle from this external point.